Hello and welcome back for another math lesson. I put a couple of problems up here for a warm-up for you. And the first problem is, name the two items and give me 3 ways that they are alike and 3 ways they are different. Now, this one might be a little bit of fun for you today. The second problem is a word problem, and it's Mrs. Groth received a lovely gift from her students. It all started at 8:45 when she went to the spa for an hour and 35-minute treatment. Then she sat by the pool for 2 hours and 10 minutes. Next, she had a 45-minute lunch. After lunch, a limo picked her up and brought her home. The limo ride took 35 minutes. What time was it when Mrs. Groth returned home? Why don't you pause your computer and work on this, and we'll get back to the answers in a minute. The next part of our lesson is figuring out some fractions. And the first thing I want you to know is this rectangle represents one whole. So if I took that rectangle and I want to cut it into half, I could do it a few different ways. I could cut it into half, going right down the center. Now that's hopefully close to half. It's not going to be perfect, but it's close. Or I could cut it into half going this direction. I bet you see another way or two I could cut that into half. Now, I'm going to take this rectangle, and this time I want to cut it into quarters. Think about it for a second. How would you go about cutting into quarters? I'm going to start the same way I did this one. I'm going to cut it in half. In fact, I'm going to come right down from this one. Then I can take that half and cut it into half. And I should end up with quarters. Now I'm going to take this one. I'm going to cut it into quarters also. And I might do it this way after this one. I might cut it into half. And then I'm going to cut my halves in half. And for each of those, I then ended up in quarters. So I'm going to cover in half of this one. And I was wondering if you noticed something. That when I colored in half of this one, I could color in half this one. And hopefully you realize, or you recognize that 1/2 is the same as 2/4. So 1/2 equals 2/4. Those are both equivalent fractions. That's going to come in handy when you do your assignment today. Our assignment we're going to work on today is you have to find your student book and turn to page 213 and 214. And you're going to see a page that looks something like, let me stop this for a second and I'll find it for you. You're going to find a page that looks something like this. In fact, you're going to find 2 pages that look like this. And your job is to find out how many different ways you can find to divide this geoboard into halves. Okay? I want you to try to do the first 3 on your own right now. I'm going to pause it for a second. And you can draw 3 different ways to cut those into halves. Now, I know that some of you right away said, I'm going to do the really easy one. And you drew a line straight down. Cut it in half that way. This side's equal to that side, and they're both 1/2 of a whole, so that is half. Some of you might have said, I'm going to cut this one. This half is congruent to that half. They're exactly equal. And then someone else might have said, oh, I'm going to do it this way. Now you've done it, if you did those 3, you did 3 of the easiest ways. Now, what I want you to start thinking about is think about some ways to cut the rest of your shapes into half. One thing that might help you when you're thinking about this is when I looked, I noticed that I had 1, 2, 3, 4, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 squares on my geoboard. So on this I had 16, and now I'm going to have half. I'm going to have to get, what's half of 16? Oh yeah, 8. I'm going to have 8 out of 16 on each side. Now this one, I can tell I have 8. This one's a little harder. I have 1, 2, 3, 4, 5, and this one together would make 6, and these two together would make 7, and these two together would make 8. So I do have 8 on there. Okay? What I want you to do is on this page and the next page, figure out how many different ways you can cut this into half. And I'll show you a couple of the ways that I did it. Okay, I'm going to show you some of the other ways that I found to cut it into half. Now, when I say to cut it into half, all my halves don't have to be the exact same shape, but they have to take up the same amount of area. So when I cut mine into halves, I'm going to skip this one and come back to it. I'm going to start with this one. And all I made sure is that I had 8 squares on each half. So I drew this line, and I counted. I had 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 on this side. There are 8 on that side. So that's exactly in half. They have the exact same area. I drew another line going down this way, and I counted, and I made sure that I had 8 on each side. Now this one, again, I just drew a line over here, making sure that I had 8 squares on each side. Now these two, you're going to notice that I had a diagonal line. And when I took the diagonal line, before I told you if I cut this into half, I need 2 pieces to make a whole. So I had 1, 2, 3, 4, 5, 6, 7. Then I had 2 halves of that last square, and 2 halves together equal a whole. So that gave me 8. And this one I did the same thing. Now you can take some more time and see if you can go through and find some other ways to cut yours into half. Today, instead of taking pictures of all of these pages, I want you to just find the one that you like the most and try to get a close-up of that page. And then you can also take a picture of page 214, which is going to be your assignment for today. So I'm going to go back over those other problems with you today that we did. So take those out, please. Okay, I don't think I tricked you about the pictures. I know that most of you said this is a dog and this is a cat. And I was trying to think of 3 ways they're alike. Now, when I did this, I have to make sure I use the word they both. So they both have fur, they both have 4 legs, they both have 2 eyes, they both have tails, they're both mammals, they both have paws, they both have claws. You can probably come up with a lot more than that. Now, how are they different? Let's see, most cats have pointy ears, most dogs have floppy ears. How else are they different? I know that most dogs, they kind of like to bark. Most cats like to meow. Most dogs are kind of friendly. They're going to come up to you. A lot of cats are kind of finicky. They might not come up to you unless they really know you or they really like you. I do know something that most dogs go outside when they have to go to the bathroom, and most cats will go in a litter box. So those are just some of the ways I found that they're alike and different. Now let's go down and try to solve Mrs. Growth's problem. To do Mrs. Gross' problem, I'm going to start out by using a timeline. I like to do a lot of problems on timelines. So I'm going to start here at 8:45. And I knew her first treatment was 1 hour and 35 minutes. I like to make my big jumps first. So I'm going to jump 1 hour. And I like to write my hours inside the loop. So 8:45, 1 hour is going to get me to 9:45. And I still have 35 minutes. I'm going to jump 5 minutes. That's going to get me to 9:50. I had an hour and 35 to go. So I used up the hour, I used up the 5. I still have 30 minutes left. And I'm going to jump 30 minutes. That's going to get me to 10 minutes is going to get me to 10, 10, 10, 10, 20. So I'm now at 10, 20. Now, I know she sat by the pool for 2 hours. I'm going to take that big jump of 2 hours again. And I'm going to put my hours down here. 2 hours is going to get me to 12, 20. And I still have 10 minutes left. So I'm going to take my 10-minute jump. That's going to get me to 12, 30. So I'm done with her pool time. Now she ate lunch for 45 minutes. I'm going to jump 30 of those minutes. That's going to get me to 1 o'clock. And I had 45, so I know I have 15 minutes left. And that's going to get me to 1:15. Now, a 35-minute ride home. So I'm going to put my 35 minutes down. I'm going to take a 5-minute jump. That's going to get me to 1:20. And I still have 30 minutes left. That should get me to 1:50. So Miss Growth would have got home at 1:50 to enjoy her husband and children. I'm sure she's very happy with the gift that you guys gave her. I misspoke on the page. Your page to do today is page 215, not 214. We just did 214. So go ahead and work on that page. Anybody that wants to hang out with me again, I'm going to do a couple of more enrichment problems for you. So I'm going to pause it for a second here, then I'll put up the enrichment problems. If you don't want to hang out with me, just go ahead and do page 215 and take a picture of your work and send it in. Have a great day, and I'll be right back with those that are staying with me. Okay, this is your first extra problem today, and it's going to be a perimeter and area problem. Why don't you copy it down, take a couple seconds, figure out the answer, and come back and check with me and see how you did. Okay, to do this problem, to find the perimeter, I remembered that it's side plus side plus side plus side till I run out of sides. And I wrote the 22.3. Right underneath it, I wrote 22.3, making sure to line up my decimal points. So whenever I add numbers with decimal points, I want to line up the decimal points. Now, you might notice that I wrote down the 5 as 5.0, because 5 is exact same as 5.0. And it just makes it so I have a decimal point so I can line up in 5.0. So I'm going to line up going down. 3 plus 3 plus 0 plus 0 is 6. And my decimal point in addition and subtraction is just going to come straight down. 2 plus 2 is 4, plus 10 is 14. Put down a 4, carry a 1. 2 plus 2 is 4, plus 1 is 5. So hopefully you ended up with 54.6 centimeters for your answer. Now, our next problem is a multiplication problem. And I told you before that whenever I have a decimal point in a multiplication problem, I forget about it till the end. So I'm just going to multiply 5 times 3 is 15. I'm going to put down my 5, carry a 1. 5 times 2 is 10, plus 1 is 11. Put down my 1s, carry my 10s. 5 times 2 is 10, plus 1 is 11. So my number looks like this, but now I have to deal with the decimal point. I have one number past that decimal point, so I have to move my decimal point over one spot. So my answer is 111.5 centimeters squared. Okay? I'm going to put up one more area problem for you. This one's a little bit more difficult. Again, it's one of those that you have to break apart. You can figure out the area and perimeter of this one for me, and I'll be right back with you. Okay. Now, to figure out my perimeter, I just wrote down all my sides. I'm going to add them together. 8 plus 9 is 17, plus 2 is 19, plus 5 is 24, plus 10 is 34, plus 14 is 48 centimeters for perimeter. Now, I like to do this. I cut my L into 2 rectangles, and I like to do mine kind of color-coded. It makes things easier for me. Now, I have to find my 2 sides for the green rectangle, and I found out my 2 sides are 9 and 8. Some people might say my sides are 8 and 14, but you're going to notice that 14 is part of the red too, so I can't include that 14. I have to just get my 2 long green sides. So I'm going to have 8 times 9. Hopefully you guys remember 8 times 9. If you don't know 8 times 9, I'm going to do 8 times 10, which is 80. I'm going to take away one group of 8, which is 72. So this is going to be 72 centimeters squared. And this side, oh, easy problem. My 2 sides that I know are 5 and 10. Now don't take this 2, because this 2 is just that little part. I have to get the whole length of the red. So 5 times 10 is 50. So that's 50 centimeters squared. And 72 plus 50 is 122 centimeters squared. Hopefully that's what you have. And when I told you I had one more problem for you, I didn't tell you the whole truth. I still have one more for you. Here's the last one for today for sure. Go ahead and try to figure out this one. This one I want to know the area of the unshaded part. So I don't want to know that. You have to do something with the area of these two, but I want to know how much of this shape is unshaded. I'm going to pause it, and you can figure it out, and we'll come back and check the problem together. Okay, to solve this problem, what I had to do first, I'm going to find the area of the big rectangle. And I'm going to do 19 times 8, and I decided to do an area model. 8 times 10 is 80. 8 times 9 is 72. So I have to add those two together, and I get 152 centimeters squared. Now, I know the area of this whole thing is 152 centimeters squared, but now I'm going to have to take these two areas and subtract them from my total. So 2 centimeters by 2 centimeters would give me 4 centimeters squared. And 4 centimeters by 4 centimeters would give me 16 centimeters squared. So those two spots that were shaded on the inside together are going to be 20 centimeters squared. So I have to subtract that from here. I get it up with 132 centimeters squared. Hopefully you enjoyed the enrichment math. Have a good day, and I think I'm going to be back with you tomorrow. So we'll see you later.